Number 4 says, use the standard form of a polynomial function to describe the end behavior of each function given below. Now, these are already in standard form, so we do not have to write it in standard form, right? Standard form is there's nothing to be multiplied out, and the terms are written with descending degrees. So all of them are already in standard form. Now, the great thing about standard form is that once you have that, this leading term is everything you need to look at to describe the end behavior. And there's a couple pieces of information in there. If the leading term has an odd numbered exponent, we know that the end behavior is going to go in opposite ways. It's either going to look like this, right, the end behavior, or the end behavior is going to look like this. But the two pieces of the ends are going to be opposite of each other. But if we have an even degree, we know that the two arms of the ends are either going to both be up or both be down. So that's what looking at the exponent tells you. So for this one, I know it's going to be one of these two. This one, I know it's going to be one of these two. This one, I know it's going to be one of these two. And this one, I know it's going to be one of these, right? So now to tell the difference between whether it goes up or down, I look at the coefficient of the leading term. And if it's positive, I know that it's going up. If it's negative, I know that it's going down. So here, when you're talking odd degree, if it's negative, I know that it's going to go down at the end. And if it's a positive leading coefficient, I know it's going to go up at the end. So I'm just going to draw a picture. Remember, we used our arms to describe end behavior. So I'm going to imagine these are your arms. This one, the arms are going to go like this. This one, the arms are going to go like this. This one, the arms are going to go like this. And this one, the arms are going to go like this, right? So if you get that far in understanding end behavior, you've gone pretty far to showing that you really understand, right? Especially if you can explain how it's related to that leading term. But we want you to be able to write this in a kind of notation that mathematicians use. So mathematicians basically, remember, this is saying if I go to the left, I'm going to go up, and if I go down, I'm going to go to the right, right? So, but mathematicians use a notation where if I go to the left, I'm talking about x going to negative infinity. So if I go to the left, then I'm going up. So that's saying y is going to positive infinity. So this is a mathematical sentence that says, if I go to the left, then I'm going to go up. And now I need to write one to describe this arm. So this sentence described this arm. Now I need to write a sentence to describe this arm. If I go to the right, so if x goes to positive infinity, if I go to the right, then y is going to go down, right? Y is going to go down, and we say that as negative infinity. So if I go to the left, y is going to go up. If I go to the right, y is going to go down. I'll write one more like that, and then you need to do C and D. So here, we've got something that looks like this. So I'm saying if I go to the left, I'm going up, right? So if I go to the left, we're talking about x's, and we're talking about x's going to the negative side of things, right? So if I go to the left, then what happens is my y goes up. So my y is going to positive infinity. But now what happens if I go to the right? If I go to the right, we're talking about x is going towards positive infinity. If I'm going to the right, then what do my y's do? My y's still go up. My y's still go to positive infinity. So this is a picture of end behavior, and this is a math. And when I was saying going to the right, I go up, that's an English way of saying it. This is the math way of saying it. So you need to take it, the idea is to take it to this level. This would be more like a 2 on a test. Being able to write it in English would be more like a 3. This is more like the 4s and 5 area.